Well, my fellow coders, welcome to this Facebook Live session where I was doing one last week and I made the mistake of not sharing my desktop screen with you while I was doing the presentation. So I had to scrap that presentation and now I'm redoing it. So let me go ahead and, well, first I need to share this with my other group because I like to share as much as I can with all these live broadcasts to all the people that follow me. And while I'm doing that, I'm going to talk about today's problem that we're tackling. Essentially, what we're doing today is around a question around something called the Knights Tour interview question. Well, it's not a Knights Tour interview question. It's a Knights Tour question, but it happens to also be an interview question. And the interview question asks you to take a knight on a chessboard. So if you're not familiar with what a knight is on a chessboard, I guess we'll have to talk about that in just a moment. Hold on a second while I say, how do I say share this? Here we go. The knight moves sort of in an L format on the chessboard, but like I said, we'll talk about that in a second. But the idea of the Knight's Tour is you start at any position on the chessboard and you move the knight around the chessboard such that it will land on each square of the chessboard once and only once. So you can't revisit the same spot again. So it's a pretty cool little algorithm, and you would think that there's not too many possible solutions to the problem, but apparently there are tons, like in the trillions or billions or something like that. I think it was billions or millions. I don't know. There's a whole bunch of different ways and combinations that you can solve this problem with an algorithm. So that's pretty fun stuff to know. So there you go. I've shared my stuff with my other group. So now what I'm going to do is I'm going to switch over to this view where we can actually see my desktop screen, because I'm not going to forget to do that this time. So I'll tackle in sort of in some code and write out some of my thoughts and my thought process around what I thought when I first tackled this interview question, and sort of where I went wrong when I first did the interview question, and what I realized sort of too late. Anyway, so we'll talk about that right now. So let me go ahead and start up a new project. I'll say file new. For those of you who are on your cell phones and can't see this, I'll sort of verbally say what I'm doing. The actual text on the main area of the screen will be much bigger, so you'll be able to see that. So I'll say file new, and I'm going to say Java project. Just create a plain old Java project. I'll call it Knight's Tour question. And I'll say finish. I'll just give me a plain old, Java app with nothing inside of it. It's not a web app or anything, nothing fancy. And I'm going to right click in the source directory and say file new, or just new, and then I'm going to choose a new class. And I'm essentially just going to call this the main class for the lack of a better, name of it. And I'm going to check the public static void main string args stub so that it will just automatically generate a public static void main string args. If you don't know what a public static void main string args is, then perhaps this live session will be a little bit too far over your head. You probably need to do a bit more learning before you can dive into this. But I mean, feel free to listen, soak in all that you can. I guess we're more or less going to be talking about more algorithms necessarily than Java code, but we will be obviously talking about Java code as well. And then I'm going to create a new class. I'll call it the new Knight's Tour. And I'm just going to create this from the new keyword. I'm saying new, and I'm going to right click or hover over it and say create new class, because I'm lazy. And then I'll say, go, and then I don't have to type in that stuff again if I don't want to. Cool. And we'll create a Knight Tour constructor. And in here, we'll do some initialization and so on and so forth. But before I jump into that, at the top here, I'm going to add some comments, and we'll write out sort of my thought process around this interview question. So, like I said, Knight's Tour means you have a knight on a chessboard of n by n size. That means it can be any size you want it to be, essentially, within reason. I think there probably is a minimum size it can be, probably 2 by 2 or 3 by 3 or something. So it's n by n size. How can you move the knight on the chessboard such that the knight visits each spot on the board, on the chessboard, once and only once? And it traverses the entire board. That's essentially the problem that we are trying to solve here. So what happened? So when I was doing my Amazon interview, I think this is the last question. I think they ask you, I can't remember now. It was so long ago I did it. It was like 3 or 5 questions, and I think they gave you a decent amount of time too. I think they gave you like an hour and a half or something. But even then, you go into it thinking, "Oh, I have an hour and a half to answer all these questions." By the time you hit the last question, you're still under a time crunch. So I believe this was the last question. So I didn't spend a lot of time thinking about the problem. I spent more time thinking about how I was just going to sort of brute force it and jump into it. So the first thing that I think whenever I'm tackling any sort of interview question is I always go to the hash map, okay, or hash table, whatever you want to call it. That's always the sort of data structure that I go to. I take a data structure approach. Now, the reason why I do this is because the majority of the questions that are asked in interviews, I don't want to say the full majority, but a fair number of them, like, maybe anywhere from 25 to maybe 45% of the interview questions you're asked can be solved through the use of a data structure, or maybe a tree or something like that, like a binary tree or something. There's typically a data structure solution to the questions that they're asking, okay? I would say that that's probably above 50%. Above 50% of the interview questions you're asked are going to need to use some sort of a data structure to solve that interview question. So I start with that in my mind. So I started to sort of tackle this problem with that in mind. So the data structure I was looking at is some sort of an array, right? In this case, I thought about a hash map, but I was like, well, you have a chessboard, and a chessboard is kind of like a multi-dimensional array. So therefore, I immediately went to multi-dimensional array, and I discounted hash map, and I said, that's probably the data structure that we're going to go with this solution. And I really dove into it, and I really stuck to that. Now, the problem with that was, there wasn't a problem there. You absolutely need to use a multi-dimensional array to define a chessboard and so on and so forth. The problem was, with my algorithm, I realized too late that I hit a problem and I couldn't solve it. Probably couldn't solve it at all with the way I was doing my code. And if I could solve it, there was no way I had enough time to solve it. So what I had done was I started doing the obvious thing. I started to tackle this problem with, you create a chessboard with a multi-dimensional array. Great. N by n size. So you pass in, you allow the constructor to pass in, your size of chessboard or whatever, which is great because then you can initialize an n by n chessboard, right? Which is just going to look like, you can just say, int. I say int because I'm going to be storing the moves, how many moves, like which. So if you start at position 1, that's sort of, number 1. And then the knight will move to another position, and then that'll be the second move. And another position, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. As it moves around the board, I keep track of which number of the move it was so that you can sort of backtrack and see exactly, you can prove that with the numbering system on the chessboard in the multi-dimensional array that you visited, each spot once and only once type of thing. So we'll create the chessboard equals new int size of chessboard, right? Really, I should have defined this as n because that's the whole point, where size of chessboard equals n in this case, right? So great. I define the size of it, and I define the fact that I want to sort of keep track of the number of moves with an integer, multi-dimensional integer array. Cool. And then I started to program in the logic for moving the knight around, right? So I said, okay, how can a knight move? A knight can move up and left, up and right. Well, let's write it out. So the knight can move thusly. Anyway. I'm in a good mood. I got a decent amount of sleep, so I'm feeling a little bit playful. So I can move up and left, up and right, right and up, right and down, down and left, down and right, left and up, right and up. So those are sort of the 8 moves, right? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 different ways a knight can move on the chessboard, where the first move is 2 spaces, and the second one is 1 space. So if I go up and left, I'm moving up twice and left once. If I'm moving up and right, I'm moving up twice and right once. If I'm moving right and up, I'm moving right twice and up once. So instead of, you know what I mean? The difference between right and up and right, the difference between these two is we're moving up twice and right once. And here we're moving right twice and up once. That's the difference between, you know, the up and right and up. You probably already knew that. Most people know that, but just in case you didn't, there you go. Now I've explained it. So, cool, right? That's, you define the moves. These are all the ways that the knight can move. So then you just need to make sure, that, when you move, you are within the bounds of the chessboard, right? So how do you find out if you're within the bounds of the chessboard? Well, each position on the chessboard has a coordinate, an X, Y coordinate, where 0, 0 is the bottom left, and, N, comma, N is the top right. Right? So if you're outside of 0, 0 and N, N, then you're outside of the scope of the board, so you can just say, no, you can't move that way. So that's sort of what I was doing. I was hitting my stride. I was writing my functions to do all these moves and whatnot. But what I was doing was I was just sort of moving around at random, and I wasn't moving around with any sort of purpose. And I didn't really realize that I didn't really envision tackling the problem of whether or not I had already landed on a particular square on the chessboard. Okay. And by the time I got to the point where I was running the code and saying, okay, he's the knight piece has hit the same spot more than once, I was like, oh no, how do I do this now? And I was like, okay, so how do I check and make sure that the knight piece hasn't already visited this square before? And at that point I was done. I was cooked. So to write the code to sort of figure out that out, it was just too difficult. So whether or not, so you may or may not understand, or you may or may not be thinking about the proper solution here, but there is a sort of a good way to tackle this problem. And in this long speech that I've been giving in the past, I don't know if there's a timer on here telling me how long I've been talking, but in the, 15 or 10 minutes, whatever it's been that I've been talking, I said a very important word once. I noted it as I was speaking out loud. I noted the word, and I said it once, and that is the tip-off with respect to what I should have done from the beginning when I was writing out this code originally in the original interview with Amazon. Because if you're just joining, when I was doing this interview with Amazon, I hit this question, this Knight's Tour question. I did it incorrectly. So I was like, oh, shoot, because I just ran out of time and I was trying to sort of brute force it and I wasn't really thinking ahead. The key word that I had said in this particular live chat that we're doing right now on Facebook, or if you're watching this on Google as a replay, then on Google, on YouTube, I said the word backtracking. I don't know if you heard me say that word. I was talking about moving through the chessboard, and I said, if you landed on a square that you've already landed on, you should backtrack out and do something else. That's the key, backtracking. So whenever you think of the fact that you might need to backtrack and try a different problem, essentially revert to a previous state of the application to try a different path. Does anybody know what that represents? Does anybody know the solution that goes along with the word backtracking? I'll let you take a moment and think about, there's only a couple people watching right now live because these are long lives that I do. If you're watching and you do know the answer to this question that I've asked, you can feel free to post it in the comments. I'll give you a moment. Again, you're going through and you hit a spot where it's like, oh, no, that's not the right move. I can't do that. I need to backtrack. I need to revert to a different state, a previous state of my application to try a different path. What concept is that in programming? So no one's saying anything yet. Obviously, that's fine. Probably most people haven't followed through this entire thing. So the answer is recursion. This is a recursive algorithm problem. So as soon as I hit the point that I realized I need to backtrack, I was like, oh no, it's a recursive problem. Shoot, because then I didn't have enough time to go and rewrite my whole code base, well, not code base, but my entire application to solve this problem using recursion instead of the whatever other method I was using. So having said that, let's try and solve this using recursion, okay? So this is where the proverbial rubber will meet the road. So let's get coding. So first up, I want to sort of define the movements for the knight. I want to be able to define how the knight can move in code. So I'm going to create a method called public. We'll do void just for now. I don't think it needs to return anything. And we'll call this try to move or something like that. Okay, but then the try to move needs to take essentially two integers, the x and the y direction, right? X direction and y direction. We want to try to move in the x direction as well as the y direction. And then we can obviously try to move. So there's a couple things we need to do here. Check and make sure that the move is within the bounds of the chessboard. And we need to check and make sure that we haven't already visited the spot we're moving to. Okay, those are sort of the two, those are sort of the two things that we need to make sure that we do when we're doing this particular method. So how do we do that? Well, it's actually fairly simple code to do this. First to check to see if we're within the bounds. We know the bounds of the chessboard. The minimum you can be is at 0, 0, x, y, and the maximum you can be is what, n minus 1 in the x and y position. Again, zero-based. A chessboard of size 8, 8 in a zero-based indexing system starts at 0 and ends at 7, right? It doesn't go to 8 if it's a size 8 for n because it's zero-based indexing. You reduce 1. So again, common thing that people always forget about. So let's check and see if we're in the bounds. So if the we also need to know the current position that we're in, right? So how did I do that before? How did I keep track of the current position? Did I pass that in? I might have passed that in. So let's create, how do I do this? Let's do a node. Again, so I shouldn't say again. I'm saying this for the first time, but I've said this in many of the past Facebook Lives. This session, I haven't actually written out this code yet. This is pretty much the first time that you're seeing me write out this code. So that's going to be this is a very informal, very preliminary, whatever you want to call it, just like a hacking session where you're going to see exactly how my mind works when it comes to writing this code. I think that that's extremely valuable. Most of my students think that that is an extremely valuable thing to see, to witness how I think so that they can learn how I think, because that's the most important thing when it comes to programming, is to learn how to think like a real expert programmer. Other people get very upset and they say, oh, you should have prepared more for this. This is a big waste of my time. To those people, I say, well, you can exit this live session and stop watching. Clearly, you're not the type of person that would jive well with my teaching style. So if you're the person who is upset that I haven't prepared, leave now. If you're the type of person that wants to learn how I think, this is exactly where you should be. Cool? So I believe when I was doing this, to check the current position, I believe what I had done was I created another class to represent a position, like a coordinate. You could call it like a coordinate class, or you can even call it a node. Because essentially each one of these positions that you're going to, each one of the squares on a chessboard, is essentially like a node inside of a graph, right? It's essentially what it is. It's a graph with nodes connected by the movements that you can make as a knight piece on a chessboard, right? So node 0, 0 will be connected to node, what is that? 2, 1. So 0, 0 is connected to 2, 1. 0, 0 is also connected to 1, 2, right? So those are the two nodes that are connected on this graph. So really, each square represents a node. So that's why I'm going to call it a node. And a node will have an X and a Y. The node should probably have the move count, right? So if when you move from the first square to the second, that's the first move. You move from the second to the third, that's the second move, the third move, fourth move, fifth move, all the way around the board. That's how we can keep track of the move count. And then the nodes should probably maintain a whatchamacallit, a pointer to the previous node. Just like a linked list, so to speak, right? You're sort of maintaining a linked list because we need to be able to print out our traversal. We need to be able to print out, here's how we moved through the chessboard. Okay, we'll just print out the XY coordinates. If we had a nice, someone said something. Trevor, will you upload the code after you finish the webinar? Will I upload this code? What can I do? What's the easiest way? Sure, I guess I could put it on GitHub. Yeah, I can put it on GitHub. It's not going to be the best code, but whatever. I'll put it on GitHub. So, good question. By the way, if anyone has any questions, by all means, ask. And if I peek to the right, my screen over here that I'm looking, when I'm looking this direction, I'm looking at the sort of management, the dashboard screen where I'm managing this particular live session. So if I look over here, that's why I'm looking at your comments. So anyway, feel free to ask comments or ask questions via the comments. Unless you're watching this as a replay on YouTube, I guess you can leave a YouTube comment, but I might not reply instantly if it's not live, obviously. Okay, so what I did there is I just generated getters and setters. It looks like I just wrote a lot of code. I didn't. I just generated getters and setters for all the four, what are these called? Instance variables or properties, whatever you want to call them. So I've created a node. So the node essentially will keep track of the XY, right? So I can pass in the node, the current node or the current position, whatever you want to call it. We'll call it position because that's sort of a better representation of what we're talking about here with the chessboard. So we'll call it the current position. So now we have a basis to check, right? We take the current position we're in, we apply the delta, look how smart I sound, you apply the delta of the move that we're trying to make in the X and Y direction, and then we can validate our new position against these two criteria. God, don't I sound smart? That's what happens when you get a full night of sleep. So, how do we do this? Well, it's pretty simple. We essentially have to calculate the new X, right, equals something, and we need to calculate the new Y equals something, right? So the new X and the new Y. The new X is the current position at X plus the X direction. Right? This is the X direction represents the movements we want to make in the X direction, whether positive or negative, right? And the same thing goes for the Y. The current position dot get Y plus the Y direction. Okay, simple. New X, new Y, done. We now have the new positions on the chessboard to which we can validate, from which we can validate. I don't know how to grammatically say that. So we have the validation criteria. How about we say it that way? So first thing we can check is, are we within the bounds of the chessboard? So let's do it. If chessboard at new X, actually no, that's not what we need to do at all. If we can just plain old say, we know if new X is less than 0 or new X is greater than, what's it called? N, size of chessboard. How do I guess I can say chessboard at, do that? Dot length, no. How do we do this? Chessboard dot length. Shoot, there's a way to, oh no, but I don't, it's not declared as a, whatchamacallit, a instance variable where I can, globally access it. Oops. So let's move this up. I'm going to move it up to be sort of a global thing. Oh, shoot. Now we don't have the size of the chessboard. So we'll have to initialize it as null for now. Can we do that? I'm not sure. See if it, okay. Looks like we can. Chessboard equals new int. Let's see if that works. We're just sort of making chessboard null, but we're creating it as a like a global variable almost within the Knights Tour class. We're creating it as an instance variable, so I can access it down here. I can say chessboard dot length. Although I don't know if dot length here is going to work. I feel like I need to do this, but I don't know if that's anyway. So if the length if the new x is greater than the chessboard length, but I guess it's not okay with that. The operator is undefined for the argument types int and then int. Because I just want to get the length of this guy here. Shoot, I forget how to do that. Anyway, the other way that we could solve this problem, yeah, because this says the other way that we can solve this problem is just to identify the size of the chessboard here. We can say size of chessboard. We can initialize it as 0, and then we pass in and create the instance. When we create the instance, we can apply the size of the chessboard to that. Again, same thing, global variable. That way we can say if new x is greater than... Oh, is this going to work, though? Well, hold on a second. That seems like it might work. Let's see. This might be a bug. Well, whatever. So forget about that. Let's get rid of the... This is what I mean. This is the process that my mind goes through when I'm trying to solve this problem. I didn't do any preparation work, and I did that on purpose so that you can see exactly how my mind works. Now, although in an interview scenario... Well, for this one, I was able to have access to an IDE, and I was able to use it and copy paste code and everything and use Google and all that stuff. For an interview where you're actually in person and you only have like a whiteboard, then you're going to have to just say out loud, well, there's a way to do this. If I can't remember specifically how to do it, I think it's this way. This is how I would try it. If it's wrong, I would just use Google. I think most people would be accepting of that as an explanation, because when you're coding on a whiteboard in an interview scenario, it's not real world, right? So I think they'll cut you some slack. All right, so check and see if new x is less than 0, or if new x is greater than the length, greater than or equal to, right? Because n minus 1. So you can do greater than or equal to, or you can say greater than length minus 1. Maybe I'll stick with length minus 1. So if it's greater than that, then really we just want to return. We don't want to do anything here. We don't want to try to move to that position because that's an invalid position. Okay, I'm going to get rid of my curly brackets so I can make my code more concise. And the same thing goes for new y. If the new y is less than 0, or if the new y is greater than the chessboard dot length minus 1, then we also return because we're outside of the bounds of the chessboard. Here's number 1. Okay, number 2. Have we visited that node yet? How do we do this? Well, when we're visiting a node, when we're visiting a square in the chessboard, remember that the chessboard is declared as a multi-dimensional int array, right? And there's a reason why I did that. The reason why I did that was because I want to assign a number for each of the positions in that multi-dimensional array. So imagine an Excel spreadsheet, an 8x8 Excel spreadsheet, right? You have your 8x8 Excel spreadsheet, and each of those cells in the Excel spreadsheet has an x and y coordinate. 0, 0, sorry, down here is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, or 0, 0, 1, 0, 2, 0, 3, 0, going whatever direction, 1, 1, 2, 2, 3, 3, 4, 4 along diagonal. Each of those is a node. Each of those is a position in the multi-dimensional array that holds an int value. You can put an int value into every single one of those cells on that, hypothetically speaking, that 8x8 Excel spreadsheet. So that's what's going on here. So inside of each one of those cells on the spreadsheet, or nodes in the multi-dimensional array, we can store a value. So that's what we're doing here. We're storing a value. So we can check and see if there's already a value in that particular spot on the chessboard. So we can say if chessboard, I just thought of something. Okay, I'll write this out and then I'll say why it's wrong. If the chessboard at the new x, new y, equals null or something, then we can also, or doesn't equal null, right? Then we can return, right? Because if there's nothing in there, then we can say, oh, we've already visited this spot. If there is something in there, not equal null. If there is something in there, we've already visited that spot, so that's not a valid spot to visit. Now, obviously, you can see my code is underlined here, and it says what's going on. The operator not equal to is undefined for the argument, blah, blah, blah. So chessboard with this is defined with the primitive value of int. You can't check for nulls with a primitive value of int. The default value of a primitive int declared as a whatchamacallit, instance variable, I believe, is 0. So really, you need to check and see that it's not equal to 0. However, if it is 0, I'm trying to think of, do you define the starting point as 0? I guess we can define, if we define the starting point as 1, then we're okay. Then this will work. Then if that means that 0 actually represents empty and that's never been visited before. The other solution you could do is to not declare it as a primitive int, but rather a integer object wrapper. Okay, in which case then you can say not equal to null, I believe. Right? There's two different solutions. I think either one will work, but for now I'll change my code up and say let's just use the integer wrapper. You know, no particular reason why I would choose one or the other, except for that I kind of like the concept of saying not equal to null better than not equal to 0. Right? That's kind of how my mind works. Oh, why don't you initialize a 2D array with Boolean false? So you can absolutely use the multi-dimensional array as a multi-dimensional Boolean array if you don't want to keep track of the positions. Although I see what you're saying, because I am sort of keeping track of the positions in the node. I do have the move count in the node. Okay, that's true too. We could absolutely do it that way. There are many different ways to solve these problems. So let's do it. Hey, why not? Let me take the suggestion and let me do it as Boolean. Sure. Why not? And then we can say if it is equal to true, meaning if it's been visited, then we leave. We say no, it's already been visited, so forget about that. Okay, cool. Excellent suggestion. So now we're in this situation where we've done our 2 checks. If both of them pass, if we're able to make it all the way down to line 53 in the code here, that means that we're this is a valid position that we can move to. It's within the bounds of the chessboard and it has not yet been visited. Okay, so now we need to visit it, right? So now we need to try and visit this spot. Okay? So here's where the tricky part starts to come. We need to make sure that this is a recursive algorithm. Remember I said this is a recursive algorithm we need to use to solve this problem. So recursion means it needs to call itself, right? So we need to remember that. So with recursion, you need to start, there's three parts to recursive algorithm. The first is you have a starting point. The second is you're incrementing on that. You are, making some sort of movement. You're making some sort of a change in the data set. You're calling the recursive algorithm again, and that the recursive algorithm is actually changing some sort of a value in some way, shape, or form towards an endpoint, which is step number 3. Is you need to have an endpoint. So you need to define a starting point. It needs to be moving towards an endpoint, and you need to define that endpoint. So the starting point is going to be easy. We're going to start at there's 2 ways we can do this. We can either start at 0, 0 by default, or we can pass in a start point. So we can pass in, start X and start Y, because why not? I believe that's what they said in the interview question was, define, given a starting X and a starting Y position, traverse the entire board such that you visit each square on the chessboard once and only once. So we have a starting point, and now we need to be able to iterate through, which is essentially the movement. Each of the movements, all the way through up left to, up left here, all the way down to right and up down here, we need to be able to traverse. And the end, what is the end point? The end point is we have gone through each of these moves, and every single one, you can't. It doesn't allow you to visit that position. So it's almost like the try to move should return a Boolean, right? It should say true or false in terms of you can or cannot visit this. So maybe we'll change our code here to say return false return false, and return true. Right? Maybe that's one way to make it work. So now what we need to do in here is when we try to move, is we need to actually make the move happen. So the first thing that we want to do is make sure we have the new X and the new Y set that position as visited, right? Set this spot as visited, right? So that's how we do that. And do we have to do anything else here? We set it as visited. Oh, and then we want to mark it as traversed. So I essentially want to create a new node. New position equals new node. Actually, with a node, I want to be able to pass in the X and Y. So the new X, new Y. I want to pass in the previous node, which is current position, because I need to keep track of the previous node. And I want to keep track of the move number. How do we keep track of the move number? Well, we can say integer move number equals the current one, current position, dot get move count plus 1. You just take the current position that we're in, we add 1, that's going to be the new position. So that's the move number, the current position, the blah, blah, blah. So now I'm going to hover over this and create this as a constructor, just so I can have less code. So that's going to automatically create a constructor whereby we can set all these values. So this dot new X equals new, this dot X equals new X. I guess we could just call it X and Y. We need to call it new X and new Y. This dot Y equals Y. This dot, call it previous node equals previous node. And this dot move count equals move count. Cool. So that way it'll create the node for us and populate everything from that constructor. Cool. So we've got the new position. Oh, but then I kind of want to be able to use that new position, don't I? I kind of want to return the new position node because I want to work based off of that. So maybe this should return a node. See how the code evolves as my line of thought evolves? So you're not going to write the code perfectly the first time. If you could write out all this code perfectly the first time, you don't need to be watching these videos because you're already an amazing coder, all right? Because that's impressive. So your code is going to evolve as your line of thought evolves. So really, I would like it to return the node because then we need to work based off of that node, right? We need to recursively call the algorithm to try to move again based on that node that we just returned, right? So yeah, it should absolutely return a node. So now how do we represent the return false, right? Return false means you couldn't make a move. So a good way to do that typically when you're returning objects is just to return null. Null typically means, that didn't work. You didn't get a value, didn't return anything, therefore didn't move or didn't work. Another thing you can do is you can return an empty object. If you don't like to return null, you can return an empty node. You can initialize a node with nothing in it and then check the node's values to see if it has anything in it. That's another thing that you can do if you don't like to work with nulls. It's another possibility, but I don't mind returning null. Let's say return new position. That's the node that we just created right here. Cool? All right. A lot of talking, a lot of dry throat going on. So new position, good. So now we have the algorithm that sort of defines moving in a way that fulfills our validation checks of that, it's within the bounds of the board and that we haven't already visited the spot. And if those validations are true, then we go ahead and we do the move. We actually move to a new position and return that new position on the board for that night piece. Good, great. So now we need to define essentially the recursive algorithm, right? We're at that point where we can define the recursive algorithm. So what is the recursive algorithm going to look like? Excellent question. I don't know yet. We're going to figure that out. So we need to have a starting point. Remember, recursive algorithms should have 1, a starting point. 2, an increment of some sort. And 3, towards the end point and an end point. Right? In order for a recursive algorithm to work, you essentially need those 3 properties to exist inside of your algorithm. So what's our starting point? Well, our starting point is right here. We define start x and start y. So let's create a new node called starting point equals new node. And the new node wants an x, which is start x. It wants a y, which is start y. It wants a previous node, which in this case is null, because there is no previous node. We haven't moved yet. And it wants a move count, which I guess we can say is 0. This is where I was like, do we start at 0 or do we start at 1? I don't really know. Does the first position count as I don't think the first position counts as a move. Anyway, we can argue that all day. I'll just start at 0. Cool. Boom. Number 1, done. Fantastic. Number 2, we need to increment towards the endpoint. So how do we increment this? Right? Well, we want to try to move. Right? We want to try to move. What's the current position? Starting point. What's the x direction? Well, that's a good question. What is our x and y direction? Well, the knight can move in all these different directions. So let's have him move in all those different directions. And I'm thinking about this now. When I'm saying an increment towards the endpoint, I mean through calling itself, right? That's the whole point of recursive algorithm. It needs to call itself. So I realized that the try to move is essentially where the recursion should take place. But the try to move here is not calling itself. So I need to make sure that it does call itself. Otherwise, we're in trouble. We're not doing a recursive algorithm. So the try to move needs to call itself. So it should call itself essentially by passing in a new position. So we essentially, when we say new position, we don't want to return it. We actually want to have it call itself. We essentially want to say try to move and pass in the current position, which is now new position, and an x direction and a y direction. So really our movement of the knight, up, left, whatever, up, right, should really be programmed into here. So let's do that. So let's move our comments into here. Right? We want to try to move based on these criteria. So what's up left, what's up right? Up. So this is where, remember, the first one is 2 moves, and the second one is 1 move. That's how a knight moves in an L shape. 2 up, 1 left, 2 up, 1 right, 2 right, 1 up, 2 right, 1 down, 2, 1, 2, 1, 2, 1, 2, 1. So how do we represent 2 up and 1 left with X and Y? Hopefully you guys know how to do that. How do you represent 2 up and 1 left with an X and Y coordinate? Up represents the Y in the XY. Left represents the X in the XY. So 1 left in a multidimensional array is a negative movement. Right is a positive movement. So 1 left is -1. Okay? Up in a XY system, coordinate system, up is a positive movement, down is a negative movement. So 2 up is the number 2, right? So -1, 2 represents 1 left, 2 up. See how that works? XY. And then move number. So that's where I guess we pass in move number. Right? So that is, okay, so it's not happy. Why is it not happy? The method is not applicable for node. What did I do wrong? Oh, it doesn't take a move number. So we need to have a move number. Okay, because I was passing in a move number. Is that true? Do we need a move number? The move number is captured inside of the nodes, so maybe we don't need a move number. Maybe I'm wrong there. Let's take it away and see what happens. So we're trying to move, that's your up left. Now we want to move up and right. So we still have the up, but we want to move right. So it's not -1, it's 1. Now we want to move right and up. So right represents 2 and up represents 1, both in the positive direction. Now right and down. So right is 2, down is -1. Okay. Let's see, that's up, left, up, right, right, up, right, down. Down and left is, so down first, so that means 2 down. So we have 2 in the Y. Down is negative. Left is negative, and it's also in the 1 position. Let's see, I kind of want to do this. Let me say it as 0, 0, and then I'm just going to copy. I'm doing this just so I can copy it. Oops, I turned on insert. How do I, where's my, there it is. I can copy paste a few more times, so hold on. Oh, 1, 2, 3, 4, 5, 6, 7, 8. There we go. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've done down left. Now I do down and right. So down 2 is still -2. Right is a positive movement. That's 1. Left and up. So we're moving 2 left. Left is a negative. So 2 on the X for negative. 1 on the up. And then right and up. Right is positive, 1 is up. Okay. I should probably validate that. Up and left. So 2, so this should be -1, 2. Yep. This should be 1, 2. Yep. This should be 2, 1. Yep. This should be 2, -1. Yep. This should be -1, -2. Yep. This should be 1, -2. Yep. This should be left for -2, 1. Yes. This should be 2, 1. Yes. Cool. I don't know, you probably couldn't really track that as I was saying it, but I'm sure if you went through the process of going through each one of these, doing it yourself, you would concur that these look correct. Okay, great. So now I'm questioning the concept of returning a node. Do we really need to return anything? Do we really need to return? Well, I mean, we need to be able to say whether or not it was we can move successfully or not. Because if we can move successfully, oh shoot, I don't know. Well, we'll see what happens. We will have it return the nodes, and we'll see what happens. Okay, so try to move starting point. So we've done. We're going back to the starting point part. It seems to be wrong here. So the X direction, Y direction. Oh, shoot. How do we define that as the first? I guess we can just say, because I kind of want to try. Because I don't want to pass in a direction, because the direction is going to happen right here. This is where we actually define the direction. So it's almost like I've done this a little bit backwards. It's almost like I want to have a try to move. Try to move that doesn't have an X and a Y direction. Again, this is just me hacking away. We'll see what happens. We'll see how this turns out. And then what I want to do is I just want to, well, because if I call try to move again, I'm going to need an XY direction. Shoot, so no, that's not right. That's not right. How can I start this properly? What happens when there is a pond? No, so that's a very good point. Knight steward means you have a knight on an empty chessboard. So whether or not, Kevin, your question was funny to be a joke or not. If it wasn't a joke, then yeah, that's a very valid question. What happens if there's a thing in the way? Does it know not to land on? It's an empty chessboard. It's literally just one knight on the chessboard moving around an empty chessboard, other than the fact that there's a one knight on it. So it's an almost empty chessboard. Okay, so getting back to my line of thought, trying to move with a starting point. Hopefully you guys understand the problem is that I'm faced with, right? Maybe I just pass in 0, 0 because I don't necessarily want to move anywhere. Is that a valid starting point? So I'm going to say new X, new Y. Yeah, I guess that's a valid starting point because I'm saying, yeah, move to nowhere. So move to where you are already and start there. I guess that's a valid way to start it. Cool. So very good. We have a starting point. The increments happen here as we increment through all these things. And then we have an endpoint. Well, what happens is eventually at some point, it's going to iterate through all of these and it's going to recursively go and do this and then recursively, blah, blah, blah. Eventually it's going to go through and hit the end of all of these. There's no like loop in here. There's no endless loop. It will eventually have to reach the end of the line and then move back, recursively go backwards, and then that one will move towards the end of the line. There's nothing here that's going to cause an infinite loop. And then it's just going to end up returning the positions and so on and so forth. And it's almost like when we return the new position, we want to actually print it out. So does it make sense? Yeah, we want to print out. We want to print out the current position. For validation purposes? I don't know, for whatever purposes. So let's print it out. Let's say that we have the sys out. We'll say move number is to the x position, the y position. So new position dot get x and new position get y. Put a new line so that we can like so. And then close the system out. Can we do that? Yeah, we can. That, oops. Right? Yeah. Move number is to x position, y position with a comma in between. Okay. I don't know. I feel like I don't know what's going to happen when I run this code. I feel like I'm in a position where it's more or less done. We've got an error in the main class because we need to pass in some of the arguments here. So the arguments are the chessboard, the size of the chessboard. So we'll start with an 8x8, and then a starting x and a starting y. We'll start at 0, 0, I guess. Oh, shoot. Start x, start y. Yeah, okay. All right, so let's run so after talking for pretty much an hour, this is the first time we're going to run our code and see what happens. So let's go ahead and see what happens when I run this code. Hopefully I won't lock up my computer and go nowhere. Okay, interesting. So it's done up to move. Oh, what's happening here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 41, 42, 43. Interesting. 41 appears a couple times. So, oh, where'd my screen go? Why did that? Move my screen back in there. I don't know why my screen disappeared all of a sudden. Hopefully that wasn't gone for too long. So we've got some output, which is good, and it looks like the code did finish, right? We're not the stop button. I can't click on the stop button, which means that it is stopped. So that's good. But the output here is, I guess it's going to be a little bit strange because of the fact that it is sort of recursive and we're moving backwards. But I wouldn't have would I have expected to see it say the same number twice? 41, 42, 43, 44, 45, 46, 47, 8. So at 48, it hits 48 and then starts to move backwards. Are there 48? No, there's more than 48, right? An 8x8 chessboard has 64 positions. So I feel like it should have gone further than 48. So there's something wrong with my algorithm, I believe. I think it should have hit 64. So it's like it hit 48 and then said, oh, I'm stuck, and start going back to 47, which is good. It should go back to 47, then it goes back to 46, and then, oh, so now I can go to 47 because it's found a new path. It goes 48, 49, 50, 51, 52, and then, oh, 52, it's stuck. So it goes back 47, tries a new path, 48, 49, oh, it gets stuck, 46. But I feel like it should have kept on going here. So, oh boy, how am I going to debug this? Let's see. Because this is debugging a recursive algorithm is very difficult. So, how can I do this in such a way that, I mean, it could be fine. It could be just my output is messed up, right? The algorithm could be perfect, and my output could be what's messed up. So it's almost like at the end of all this, I want to see. It'll give me a node, right? So we'll see a node. We'll call it a node. So this node that it returns, oh shoot, should it be a node to I said in here that with the node, it says a previous node. But this node, it's almost like I want to have a next node, not a previous node. Is that going to be a problem? Because I'm passing in current position and I'm saying current position get move count. I kind of want to put in the next position. So let me change my code a bit. Let me give the ability to go to the next node. So let me call this next node. No, I'll just make it doubly linked. We'll see what happens. I probably don't need this many links. We'll put in the next node, and then what we'll do is we'll say, okay, move number. At this point, we know that we're good. We need to visit this spot. So we can say, we create a new position. So we can say current position dot set next node in as the new position, right? Because the new position is going to be the next node. So that way, when we set it, I can actually get that next node and actually see what's happening here, right? So I can traverse it one at a time and see what it looks like outside of the recursive algorithm. So let's do that. Let's say while node.getNextNode is not equal to null. Node equals node.getNextNode, right? But before we do that, we want to print it out. So we'll say node.get move count. We'll just do that for now. Let's print out the move count and see what happens. Let's rerun our code. Oh, that didn't work. Let's debug, run it in debug mode. So node, there is a next node. Oh shoot, I didn't say system out. Whoops, system out. Get move count. Now we should be able to actually see that. Okay, so we see move 1, 2, 3, 4, 5, 6, 7, to 39. So we see that it's not, there's something going on. It only goes to 39, so that's not good enough. I want to be able to it to go to 64 or 63, whatever the -1 is or +1. There are a few repeats. Add a counter, maybe. In total, there is 64. There are a few repeats. Cassidy, what do you mean by a few repeats? Add a counter. Maybe in total there's 64. So yeah, just sort of explain what you mean by that. And then I'll go through the code and try to figure out where I could have gone wrong. So the new x, new y is the current position, which I'm passing in, plus x direction, plus y direction. I believe that's pretty solid stuff. That should make sense. Checking to see if it's within the bounds of the board. it will return null. And so if I'm calling it from here, it will return null if it can't move. So that, I mean, that'll be fine. It won't return null. It shouldn't. I guess, you know what? The best way to do this is to step through it. Actually step through it line by line and just see. There might be a very obvious bug that I can identify right away. There are a few repeats. 47 twice, 45 twice, 48 twice. When you were worried about it not hitting 64, you're doing something better. So, okay, cool. That's fine. No worries. I'm open to all suggestions. This is great. I love interacting with my students. So we have the debug going here. So new x, new y. Essentially, it's going to be 0, 0, right? Because we pass in 0, 0 as the x and y direction. So check and make sure that 0, 0 is a valid position on the board. Yes, it is. The board, as we can see here, is initialized with many falses, right? So it should be 0, 0 to 7, and 0 to 7 inside, right? Which it looks like it is. So that's perfect. That's an 8x8 board. All should be initialized as false. It looks like they are all false. You probably can't really see that on your phones if you're looking at your phone, but I can tell you that they're all false. So chessboard at 0, 0 will not be equal to true. So we're good. So I say, okay, chessboard at 0, 0 equals true. So now I can verify chessboard at 0, 0 is true. Yes, it is. Good. Move number equals current position, get move count plus 1. So move number will not be equal to 1. Great. New position, we do that with the current position plus the new x, new y. Ooh, what is new x, new y? Ah, there's the bug. There's the bug. So, is it the bug? Hold on. No, that's... Is that the bug? No, maybe not. Hold on. Let's let that go through. Because the new position is going to be at 0, 0, which is kind of... So that kind of means we're doing the same node twice. So that's a bit of a bug. But anyway, I don't think that'll affect too much. So we're saying move 1 is at 0, is 2, 0. So we're moving to 0, 0. Essentially, that's kind of a weird... We're not really moving to 0. Anyway, whatever. You get what I'm saying. So let me try to move again. Only we take our new position, and we're moving at -1 to 2. But when we try to do that, we do recursively calling this algorithm. When we try to do the new x and the new y, we're going to be where the new x is going to be at -1 because we were at 0, 0, and we're moving left. We can't move left. We can move up. That's going to be a valid up position, but it's not going to be within the bounds of the x. So we're going to return null. Okay, so it's going to say, oh, come back to the original recursive starting point algorithm, whatever. Go to the next one and give that one a try. My sister is texting me a very important question, and I need to answer it. And by very important, she works at a video game company, and she's asking me if I have any game requests. And since I'm a video game nerd, she says, I know it seems like a crazy question now, but there will be a time when you could start gaming again. Yes, because I have a child, and I have very little time to game. I don't know. What just came out? Anyone have I have an Xbox One. If anyone has any suggestions for cool games. I think Assassin's Creed. Sorry, guys. apparently video games trumps Facebook Live right now. Assassin's Creed. I haven't done any reviews on Assassin's Creed yet to see if probably tons more. I'll tell her that I'm doing a Facebook Live. But I'm doing a Facebook Live right now. So I can't keep going. She'll love that. Okay. So we've gone back from our recursive. So we tried to move, what was it? Up and left. We tried to move, but it didn't work. We went out of bounds. So, okay, we go back in our recursive algorithm and try to do the next one, which is up and right. That one should work. You know, going from 0, 0 up and right is perfectly valid move. So let's check it out. Boom, boom, falls within the bounds of the board. We haven't visited that spot before. Now we will. So chessboard at, what is that? 1, 2, is that what you said? 1, 2? Yeah. So chessboard at 1, 2. Come on. At 1, 2 is now true. Okay. Move number is now 2. That makes sense. Our new position is at 1, 2. We're passing in current position, which is 0, 0. Yes, it is. We're passing in the move number. Why are we passing that in again? What do we do with the current position? Oh, that's what we iterate on. Cool. That makes sense. New position. We say current position, set next node, new position. That I feel like is good. Ooh, yeah, that's okay. And then we say the move number is whatever. So we move to 1, 2. Now from 1, 2, can we move negative 1, 2? Yeah, we can. So it's going to go and recursively go in there, try and check it and see. It's going to be valid. It's going to go there, and it's going to try to, ooh, I think I know where the bug is. Okay. Ooh, I'm glad I caught that. So this is a tricky bug. This is what I think is happening. The contents or the state of the chessboard is not being rolled back as we roll back as we backtrack through our recursive process. Hopefully you understand what that means, because that's a very important point. So let me stop my algorithm. Stop the code. We declare the chessboard as a global variable, essentially. It's essentially what it is inside of our class. It's called an instance variable, but it's essentially a global variable that's global to this class. This represents the state of the chessboard. So if we move our piece around the chessboard and mark these positions as visited, great. That's great. We want to mark them as we want to mark the chessboard as visited as we're traversing. However, if we hit a point where we're at a dead end in our chessboard and we try to move, all in all 8 different directions, and it doesn't allow us to move in all those 8 different directions, we want to step back in our recursive algorithm. When we step back in our recursive algorithm, we have no longer visited that spot that we previously rolled back from. Do you know what I mean? So if we're at position, let's say 5, 5, and at 5, 5, we can't go anywhere, and we need to move back from 5, 5 to, I don't know, would that be like 4, 3 or something? We want to move from 5, 5 to 4, 3. 5, 5 is no longer visited because we just rolled back, right? We should say it's not visited. We want to roll it back. So in doing so, we're not doing that. We're not updating the chessboard. We're not saying that position is now equal to false. Okay? So I think there's two ways to do it. One way is a sort of brute force way or not brute force, but to sort of update the chessboard if we return null, right? So how would we do that? So we'd almost have to have if statements here to say if the try to move returns. No, that's not how we would do it. So no, I don't think that's a good way to do it. The best way to do it is to pass in as a variable the state of the chessboard. Okay? So in other words, the chessboard, when I was declaring it as a global variable before, was actually not a good thing. We want it to not be a global variable. We want it to be sort of a local variable inside of our night tour thing. And we want to pass that along into the recursive algorithm. Okay? Because the recursive algorithm is going to be the thing that is modifying the state of the chessboard, and the recursive algorithm will monitor the state of the chessboard. So it's going to monitor the state as it's passing the chessboard along as a pass by value. Remember Java's pass by value? It's going to pass it, and the state of it will be rolled back when it recursively backtracks. So cross your fingers that this works. So we want to pass in the Boolean multi-dimensional chessboard array. Okay, code's not happy. Where's the breaking point? Right. Chessboard. We need to pass it in to every single one of these. Chessboard. Okay, is the algorithm happy? Everything seems happy. Let's run this guy again. And let's get rid of our breakpoint and let it run through. Are you kidding me? It's still going to 39? I thought I had it that time. So am I missing something with respect to what I just said? We're initializing it. We're passing it in to try to move. We are if the chessboard at blah, blah, blah is true, return null. Then we mark the chessboard, which should be the local version of this. So it should be this chessboard that we're marking as true and visited. Yeah, and then we're passing it in to try to move recursively. So if it gets all the way through each one of these and returns back, I believe it should revert to the previous state of the chessboard when it goes back to a previous, steps back, and then, maybe it tried to do this one and it went into that one and it did all the 8 moves and it couldn't go. So then it comes back to here and it goes to try to move. That chessboard now is the previous local version of that chessboard in that particular recursive state. It's very confusing to explain. It's much easier when you see the visualization of recursion. So that should be okay. I feel like that should be okay. So the other question is it just not possible to complete this algorithm from position 0, 0? I doubt it. I was under the impression that there's lots of ways to solve this algorithm. Let's try, instead of saying 0, 0, let's just say 5, 0 or something like that, and just see randomly. This only goes to 33 now. See, what's maddening is I'm not entirely positive. Well, no, I am pretty... Because at some point I should see this number go up to 64. So no, something's up here. If we say 5, 1 and run it again, we get up to 52 there, but still 0, 0. Did 0, 0 hit 52? Let's see. 0, 0 hit 52. Are they all hitting 52? Let's try starting at like 7, 7. Something. The edge of the board. That hits. See, that didn't even get to 52. So I can see that something is happening that's different. We're getting different outputs, which is good. There's another bug in here. Okay, fair enough. So let's debug it. I saw another comment just came in, but I don't see it in my dashboard. I need to wait in the dashboard for the comment to come up. Let's see. So let's go back and debug and see if we can validate that what I said I'm doing with respect to passing the chessboard is actually happening. So let's go ahead and debug. I guess I can always go into my app, although it might play the video that I might be playing the live video as I'm recording the live video. Oh, sorry, it's not one of you guys that commented. All right. So let's see. We are starting at 0, 0. Blah, 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 blah. Chessboard's good. We set it as being equal to true. We do our move numbers. We mark it down that we moved. We try to move again. So now this chessboard that we're passing in should be true at 0, 0. Good, it is. We go through. We try to move. New X, new Y. Boom. So now the chessboard is 0, 0, and then 1 something. Where is it? 1, 2. Cool. So let's say it's working. Now we're at 1, 2. Now we try to move back left and up. We should be able to do that because it's 0, 4 now. That should be valid. So 0, 4 should now be marked as visited. Yes, it is. Great. And we mark that as 0, 4. And then we try to move left again. That one will not work. Returns null. Then we try the next move, which is 1, 2, which gives us 1, 6, which sounds valid to me. Yep, it's valid. We move up to 1, 6. We try to move back. this should be out of bounds because we're too far up now, right? We're at new y of 8. So the x will work, but the y will say, nope, good. So the y doesn't allow us. Go back. So now we're going to try to move from, again, we're in, what position are we in right now? I guess we're at 1, 6. So now we're going to try to move to 2. Yeah, we're going to try to move up again too far, and that's not going to work. Nope, so return null, good. So we can't move up that far. Now we're going to try to move right twice and up once. So that will work. Should work anyway. Yep, there you go. And mark it as true and visited. Fantastic. And then from 3, 7, we try to move left and up. And that's not going to work because we can't move up. Good. And we try to move up and it won't work because we can't move up. Good. And then we try to move right and up. And we're right at the top of the board, so we can't move up at all. So it's going to say, good, return null. And then we're going to try to move right and down, and that will work. Yes, we haven't visited there. Great. Mark it all there. Boom, we're at 5, 6. Now we try to move left and up. That will not work because that's too far up. Good. We try to move up again. Too far up won't work. Good. We try to move right and up. That should work. We'll be at 7, 7. So now we're going to be at the very top right-hand corner of the board. Yep. So now we're at 7, 7. Look at that, 7, 7, and 7. So now we're in a situation that we can only move in the negative directions. So the only one that we can move in is going to be this one. So that won't work. That won't work. That won't work. That won't work. This should work. Well, at least I think it should work, unless we've already visited which 6, 5. I don't believe we visited 6, 5. So I think what I can do here is what I'll do is I'll let this run through, and what I'll do is I'll watch until I get to the point where there is a backwards recursion point, which I thought was around 40 something. So let me just let this run through, because really the situation, like, it looks like this is good. We're stepping through the algorithm. It looks like it should be fine. Your own pawn, it should not land. If opponent's pawn, it takes away. I think Kevin is confused. So, okay. Yeah, Kevin, we're talking about something called the Knight's Tour. You probably joined late. Again, we have an empty chessboard with one knight that's moving around the board. And the trick that we want to do here is the knight should visit each position on the board once and only once. That's the algorithm. That's the problem that we're trying to solve, is moving a knight around a chessboard without visiting, with visiting every single spot on the board once and only once. And remember, it's an empty board, so there's going to be no pawns in here. It's just the knight. Okay, let me run it through, and then I want to see where it starts to backtrack. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5, 6. Okay, so 45 is where the first time with respect to the moving, with respect to having an issue. So what I'll do here is I'll put a breakpoint with a condition. Here's a cool thing. I don't know if you guys know how to do this. You can put a breakpoint, like you would always put a breakpoint. You can right-click on the breakpoint, and you can say breakpoint properties. So I did a right-click on the breakpoint. I'm going to breakpoint properties. And in here, I can make it conditional. There's a little checkbox. You probably can't really see it if you're on your phone, but there's a conditional checkbox that says suspend when true. So I want to suspend my code when a particular state is reached. Excuse me, what state do I want to pause my program in when it hits that state or whatever? I want to say when move number is equivalent to 45. If move number is 45 at that breakpoint, I want to actually break. So I'm going to say, okay, so that's a conditional breakpoint. So now I can run my program, and it will break. See what happened there? It went to move, and then it hit move 44, and then it hit the breakpoint. So it says move number is now 45. My conditional breakpoint has done its job. Now I can start to see what's going on. So at the point of move 45, I'm at 0.6, which I assume I've never hit 0.6 before. 0.4, 0.7, 0.5, Yeah, never hit 0, 6 before. So now from 0, 6, I'm going to try to move left, which it's not going to allow me to. Oops. I need to put a breakpoint in there. It won't allow me to move left. I'm going to try to move up and right. I can't move up. It's going to try to move right twice and 1 up. Right twice, 1 up. So that's a valid move, but I might have already visited that position because that's 2, 7. Have I visited 2, 7 before? 2, 7. Yes, I've already visited 2, 7 as of move 26. So it's a valid position to go to, except for the fact that I've already visited. So these checks are going to be good, but the chessboard at 2, 7 is going to be true. So I'm returning null. Excellent. See, that's exactly what I want my algorithm to do. So the algorithm's working beautifully right now. Okay, go to the next one. The next one is move right twice and down, which we can. So have I moved to 2, 5 before? Look for a 2, 5 in here. 2, 5. I did that at move 32. So again, valid position in terms of an XY, but 2, 5 has already been visited, so I return null. Excellent. What about -1? No, I can't move left, so this is going to be return null. So I can move here. That's going to be 1, 4, but I did 1, 4 in the previous move, so that's a valid XY, but not a valid position because I already visited, so it's going to go back. -2, 1. So no, I can't move left. 2, 1. That's going to be 2, 7. I believe I visited 2, 7 already. 2, 7. I visited to move 26. Okay. So return null. Good. Here's where the current position is 0, 6, right? And the chessboard in 0, 6 is true, right? The state of the chessboard right now in this particular instance of the recursive algorithm. I saw Kevin apologize. You don't have to apologize, Kevin, for saying you didn't know. That's cool. No worries. I'm not going to punish you for joining late. So the situation we're in right now is the state of the recursive algorithm right now in this particular page or whatever in a thread. Like, look at the thread, right? Look at how many how deep we are in the try to move. We're 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 all the way to this one deep. We're probably 45 pages deep, 45 threads, not threads, but 45, what's the word, iterations of the recursive algorithm deep. So at this point, the chessboard at 0, 6 is marked as true. But now we're moving back. We made it to the end of all of this stuff, and we're at an impasse. We don't want to be here. This is not the right position to be in. So we need to move back a page. So we move back. Now that we've moved back, the chessboard should no longer have move 45 as visited. Or yeah, exactly. Move 0, the 0, 6 should not be visited. So let's see what the state of 0, 6 is. See, it says true. And I think that's the bug. I think that's the problem. Because the state now that we moved back, because where are we right now? The current position that we're in is what? 2, 2. Interesting. The current position is 2, 2, but the new position, that one's probably that's 1, 4. Okay, so we have 2, 2 here as the previous, 1, 4 is the new position. So since we're at 1, 4, the 0, 6 position should not be visited. We tried it, but it didn't work. So yes, that's the bug. The bug here is the chessboard says that 0, 6 is true. So why the heck is that saying it's true? Because in the new position that we're the position that we currently marked as visited is 1, 4, right? 1, 4 is what we should have marked as visited. So that one should be true in this spot of the recursive algorithm. But again, we move forward to 0, 6. and marked it as true. So I thought this was a property of recursion that it would roll back the state of that chessboard. So apparently that's a misconception in my own brain. Kevin says, is it spinning around the board correctly? Yeah, no, it's moving perfectly. The algorithm, the knight is moving beautifully through the board. It's observing all the rules that I'm telling it to, unless the rules I'm telling it to observe are false, but I'm pretty sure the rules I'm telling it to observe are true. Everything looks perfect. So the bug is, yeah, the chessboard is saying that it's been visited when at this point it should not say that it's visited, because we rolled back one position in the recursive algorithm. So it's almost like it's almost like I want to. So okay, here's what's going through my mind. So there we go. I can stop the algorithm or stop the running because I think I know I found the bug. So how do we fix this bug? One way to do it is if all of these try to moves return null, then that means we couldn't move. So we should reset the position. We should reset the state of that chessboard. I thought, like I said, the state of the chessboard would be managed through the paging and through the iterations of the recursive algorithm. Apparently not. So we need to set some sort of, Boolean can move equals false. And then we can say can move equals can move and try to move. Oh, this is going to be ugly. It's going to be ugly code. Equals null. Turn it true. I feel like it's like can move. It's did move. Oh, sorry. I'm writing this out, and I'm not saying out loud how I'm getting to this logic. So I'm trying to find out if it did or did not move. Okay. So if I assume it did move, okay, and then do an and operation, and I think it's a single, because I want to essentially change the value of did move. So we started it as true. So true and true will be true. True and true will always be true until we hit the point. Because if we hit true and false, so that's not how I want to do it. No, the way I want to say is if all these return null, if all of them return null, then and only then do I want to do something. So how do I do that? Okay, Trevor, think. If I set did move to false, false and true is still false. I feel like I guess I can do it this way. I can say did move equals false, and I can just say if try to move is not equal to null, then did move equals true. I guess that's one way to do it, right? Put it all in one line. So we say we can invoke an if statement and have the method inside of it. It'll still invoke the method, and it will return to the if statement after invoking the method. So this isn't going to change the workflow of the code that I've written, but it will do some. It will modify a value of variable depending on the return value of the method. So the method should return an object. Remember, the method returns an object down here, new position. Oh shoot! But if it didn't move, it still returns the new position, doesn't it? No. If it doesn't move, it returns null, right? Yeah, because up here it returns null. If it can't move, if each one of those return null, then yeah, that makes sense. Each one will return null. So I can essentially just do that. I think I can copy paste this code. Not the cleanest, most beautiful code, but I think it'll work. right? So if it's not null, then it did move. We said did move equal to true. And after all of this, if did move equals false, then essentially the chessboard at where did I set it? Here, the chessboard, I should set it back to false. Right? That sort of reverts back and says, oh, it couldn't move, so therefore let's remove that move from the chessboard. I don't know. I'm a little skeptical, but we'll see. Let's run it again. It's going to hit my breakpoint at 44 or 45. Let's put another regular breakpoint in so we can see exactly what happens. So it's going to go through, and it's not going to be able to do any of this stuff. Right? I'm just going to sort of quickly go through all these iterations to get down the stack of moves. Okay, so did move is false. Good. So that's what I expected to see. So if did move is false, we take chessboard at 0, 6, which is currently set to true, most likely. 0, 6 is set to true, and we set it to false. So now chessboard at 0, 6 is false. So now when we return back a page, now we're back a page, and inside of here, the chessboard, if I look at the chessboard, 0, 6 should be false. And it is. Okay, cool. So that's good. The state of my chessboard is now correct and how I would want it to be. So let's move forward with the algorithm. Let's let it run and see if anything happens. Anything different happens. So interesting. It looks like it went... So we did get different output, but it looks like it got stuck. It went to 44. It went to... Or sorry, where did it go? 45, 46, 47, 48, 52. It still didn't get to 64. Again, is that a situation where the position of 0, 0 you can't traverse it? I'm pretty sure you can. I'd be surprised if you couldn't traverse it from 0, 0. We could try 1, 0 and see if it makes, or 1, 1 and see if it makes, let's say 2, 2. That way we have a good amount of room to move from 2, 2. This one gets up to 52. Interesting, eh? It's still not happy. So there's still another bug in here, and this Facebook Live session has now gone on way too long. So this is a situation that I found myself in when I was doing this interview question. It's a matter of time, right? The time that you have to go through and execute and create the code for the algorithm for the interview question, because essentially what I'm talking about is an interview question. This is an interview question that I was asked when I was interviewing with Amazon. You don't have a whole lot of time, right? And you can't spend more than, I don't know, 30 minutes on each one of these or 45 minutes on each one of these. I've had to sort of explain what I'm doing. So in doing the explaining, while I'm coding and explaining to you guys, it definitely takes up more time. So I could be at a situation where I'm at the 30-minute mark of me just blasting away at some code because I don't have to explain it. So I could be at the 30-minute mark, but I'm still like, oh, shoot, there's a bug here that I can't figure out. It doesn't make sense. To me, everything seems perfect. Everything seems like it's executing perfectly. So then the question might be, well, then is it a problem with my algorithm? Right? Is there something I'm missing in the algorithm that I should be accounting for or something, and I'm not accounting for it? Right? Or the other thing is the output, is the algorithm correct and it's working correctly, but the output is misleading me. The output is not showing stuff correctly. So to tackle the mindset of, is the output misleading me? I believe in order for it to move correctly and do everything properly, I believe the move number would get up to 63 or 64. And I don't see that it is. So to me, I feel like, because to me, I feel like there should be a lot more in the output here, right? It's it's quitting way too early, in my opinion. What's interesting here is we have this one, the little lonely one in the output with our going through the next nodes. It's almost like it couldn't. I'm interested to see what's going on there. Let me put a breakpoint in there and run it. So we have our node. The starting node here is 0, 0. So the move count is 1. That means the node doesn't have a next node. Oh, yes, it does. Node equals next node. Okay. But this node, oh yeah, it has a next node. Move count is 2. Okay. Does this node have a next node? Yes. But then this node doesn't have a next node. So we got in 2 levels and it didn't work. Which, I mean, that could be a problem with my algorithm with setting the nodes with the, or set next node. Although I don't think so, but anyway. So, all right, what else could be the problem here? I mean, it could be like the picture I had in my mind with a chessboard, updating itself properly and having it not work with passing it through as a multi-dimensional array. Maybe the same thing is happening with respect to me passing in these objects. Maybe I'm assuming they have a state that they don't actually have as I'm passing things along. So let me try to take another stab at this for another 10 or 15 minutes, but then I'm gonna have to stop this because I need to go and actually have lunch and help my wife with my baby. So it's unfortunately I thought I'd be able to be done by now, but hey, that's what happens when, like I said, I haven't done this yet. You're seeing my mind working in real time. So this is how I think. I'm trying to teach you how I think. So since I was wrong with the chessboard and the way the chessboard propagated through the recursive algorithm, I believe maybe my thought process with the current node could be also suffering the same misconception. I'm very confident the X and the Y here, these primitive ints, are going to be working the way I expect them to work and that they roll back and everything. But perhaps the properties inside of this node are not rolling back the way I think they are. So let me explore that possibility. Let me go in and see if I could have messed up with that situation. Although again, none of my debugging made me feel like that was the case, but let's roll with it. So what do we do here? Current position.get move count. I see that this is a possible place where things get mixed up with the move number, but I feel like they would get mixed up in the direction that it would be adding too many move counts, right? Not too few. Right now, we're seeing too few move counts. We're not seeing it get up to 64. We're only seeing it up to 51 or 52 with the 8x8 array. So, yeah, Kevin says must be hitting corners. Absolutely, it's going to hit the corner. You can see in the algorithm, it hits a corner. Let's look and see where it says 7, 7. So 7, 7, or here, right here, it hits a corner 7, 7. But then it just goes and moves away from that corner, right? It goes back to the left and down, and then it goes left and up, and then it goes, so it's going to hit corners and it's going to bounce around the corners. That's exactly what the algorithm does. Here's 0, 7, that's a corner, and here's 1, 7. That's no, 1, 7 is not a corner. So what is it? 0, 0, 0, 7, 7, 7, and 7, 0 are corners. So when you see 2 7s or a 0 and a 7, that's a corner. So yes, it definitely is hitting corners, but it's moving away from the corners exactly as it should. Yeah, here's another corner, and it moves away from it. I'll say, oh, I hit the same corner again. This shouldn't do that, but I see that it's recursively going backwards here. Move 24, 24, 24. So, because it should recursively go back to 7, 0 and then try to move somewhere different, which I see is exactly what it's doing, right? So where was the 7, 0 previously? 7, 7. Show me 7, 0. 7, 2. So here's 7, 0 at move 40. So from there, it tried to, well, it looks like it's going backwards here in this. It's going backwards through the, so that leads me to believe that it must have already visited 7, 0, and I missed it. 7, 7, 7, 6, 7, 5, 7, 4. There must be a 7, 0 in here. 7, 2. Interesting. I don't see a 7, 0, so okay. Maybe I'm wrong there in assuming that it should have hit there before. But maybe, yeah, because it's going backwards, maybe it's going backwards and trying, and then it hit that. But then it couldn't move really away from 7, 0. And it tried it again back here, and okay. So what I can do, let me continue going down my line of thought with the node and possibly things going awry. So Kevin, you're explaining the directions that it can move. So that's what we're doing right here. Up, left, up, right. So you missed me talking about the try to move algorithm. So try to move algorithm takes the moving positions, X and Y, and those X and Y are represented by numbers, and the numbers represent how many positions they move. So -1, 2 represents 1 left, 2 up. 1, 2 represents 1 right, 2 up. 2 right, 1 up. 2 right, 1 down. 1 down, 1 left, 2 down. 1 right, 2 down. 2 left, 1 up. 2 right, 1 up. So that's absolutely part of this algorithm, all the different ways that the knight can move. We're going through them one by one in this chunk of code, which is part of the recursive algorithm, right? And if it can't move, it returns null up here. We do a check to see if it's within the bounds and if we haven't visited. If it's not within the bounds or we have already visited, we return from the recursive algorithm and go and try another move, so on and so forth down the line until we finally come out the other end. So when we come out the other end, eventually we're going to hit a spot where we can't move anymore. Absolutely. That's going to be the very final position, right? The final position means we can't move anymore, but I'm not seeing it get up to that final position. I need to see it get up to 64 or whatever, 63. So current position, get move count, I believe that's okay. We're passing current position in as a new position node, fine. And we're saying new position, we're instantiating a new node, fine. We're taking the current position and setting the new position in there. Yes, that could possibly go awry. That could possibly be a bug. And that's where, that's possibly why I'm only getting 2 in the output down here, is because of that situation. That could be a bug. But that, again, that's a display bug on my second attempt to display stuff. That's not in my first attempt. The first attempt here is actually just output what just happened with respect to the move. We're making the move from, the move number is going to this new position, which we're creating the new position with the new X and the new Y that we calculated up here. Current position get X, get Y. We're not changing the current position get X, get Y anywhere. So that should be fine. And the new position is taking in the new X and new Y, which are ints. They're not coming from current positions. We're not modifying anything there. It seems like it's all correct. It feels good to me. So here's the last thing I'll do is to cheat. So I'll open up Knight's Tour Java. So this is where it talks about backtracking and it talks about the path that they can follow. So here they're starting in the upper left-hand quadrant. So that is 0, 7. So we know there's a solution for 0, 7. Let's plug in 0, 7 and just see what happens. So does 0, 7 get to 60, whatever? Yeah, see, it doesn't get the 60. So something's up here. I definitely feel like when it's backtracking, like there should be so many more. When it backtracks, when it goes, so when it hits the point where it can't go any further up, the chain, and it starts to come back. So when the numbers start to come down with the move numbers, like to 43 to 40, there should be a lot more outputs here. We should start to see 33 going up, and then coming back down to 33, and then seeing that go up to like, whatever, and then come back down to like 20, and then go all the way up. Like there should be a lot of outputs, a lot of moves. So it tells me that it's almost like it's not being as recursive as it should, because it should be able to move a lot more than that. But I mean, we're calling try to move from within try to move. I mean, this is the definition of recursion, and we're passing in this new position. And is the new position being modified in any way, shape, or form? No, it's putting in the new X and the new Y. The only thing that might be wonky is the current position that we're passing in. So, I mean, one thing that we could do is instead of passing in current position and doing the get X, get Y, we can, instead of passing in the node, we could say int current X and int current Y. That would be the only thing I can think of in terms of getting rid of the possibility of the pass by value, pass by reference thing that I'm thinking of. That could be a bug. Try that. So then current position dot get move count. And then we can pass in the move count. We can just pass in everything. Right? So we can just say move count plus. Increment the move count. The new position takes in a current position. So now do we even need to keep track of these nodes now? If we're passing everything into this algorithm the way I'm passing it in, do we need to do this? So let's, because I don't think so, because we're not really keeping track of any nodes anymore. So let's say no for that for now. Move number is move count. The new get X and get Y is right here. Oops. New X, new Y, because these are valid values. And then when we say try to move, we're not passing a new position as an object. We're passing in the new X and new Y, right? So the new X and new Y. And then we also want to pass in the move count, which is here, move count. Right? So let's see if, how do I copy paste this in such a way that it's going to be good? That, okay, copy paste. And then we're returning, so, I suppose we are returning, it could be in the return too that I'm making the mistake, right? Returning values back. Should I return? I mean, it feels like I should return something because that's how we found out if we did or didn't move. So the new position, I mean, we could just say new node, right? With the new position, new X, new Y. Previous node, I guess we don't have a previous node, right? So I guess we can get rid of the previous node, next node stuff for now. Again, this is just me hacking away. Not happy about it. And then previous node. And then we don't really need to keep track of the move count either inside of the nodes, because we're doing that inside of the whatchamacallit. And again, the next node as well. We don't necessarily need next node either. Just need the X and the Y. So really new X, new Y. Right? We just return that and see what happens. So that means our while loop here is not going to work. And the starting point node, all it needs is an X and a Y. And to try to move now, it wants an X and a Y to start X, start Y, and it wants a move count, which is currently 0, and it wants an X and a Y and a chessboard. All right, so we can try that out and see what happens, because we're not really using starting point here, kind of useless. But again, it's not hitting, we get the same output here. It's hitting 40, 40. So it's not an issue of, doesn't seem like it's an issue with what I thought it could have been, which was the, passive value, passive reference stuff that Java has. So I don't know. This is a very perplexing problem. Even now, after I've had plenty of time to think about it, many late nights laying in bed saying, oh, I could use a recursive algorithm, I'm still not hitting the right solution. So there must be something wrong with my algorithm. And like I said, I got to go now. I don't have time to debug it. So I guess what I'll need to do is hack away at this code, and eventually I'll come up with a solution. And maybe what I'll do is I'll post a comment or a link to a video or something in this live stream, in the comments of this live stream, with a video of my solution or an explanation as to what the bug was, because I think maybe it's something simple. Hopefully it's something simple. I'm pretty sure it must be something simple. I'll post a comment talking about whatever the change was, and then I believe it was someone at the very beginning of this asked for a copy of the code. So I'll also upload a copy of the code to GitHub, and I'll include the link to the GitHub code in the live stream as well, so that you guys, that commented will get notified. So if you want to get notified of the changes, I don't know, I guess you can leave a comment saying following or something in here to get access to the notification that will go out when I release the fix and the code. So you'll get notification from me saying, hey, Trevor Page commented on this thing, and you'll be able to see that I left the fix there. Otherwise, you'll just have to check back, on the page or wherever. You'll have to check back manually at some point, maybe tomorrow, and see if I've posted the solution to this particular bug or situation that I am in. All right, so hopefully I'll have time to do that, and if not, well, at some point I will. So I promise you I will figure this out, and we will get to the bottom of this. So I wish I had more time. If you want to read about the actual algorithm itself, you can go Google Knight's Tour Java, and I just went to the backtracking set, and they do discuss a solution here. I believe this is the 2D array with the backtracking. So this is using the recursive algorithm solution. And as you can see they pass in X, Y, move, the solution. Interesting. X move. Oh yeah, that's what they define you can or cannot. So it looks like they're doing the exact same thing as me. They're returning Booleans though. So I'm not returning Booleans. If move I is within whatever, they're doing a for loop. Try all moves from the current coordinate. So doing a for loop, and it's saying is safe. And then it's setting that to whatever. If solve. So this is interesting, return true. This is something I need to look at. And then the else. So I don't know if I do this kind of thing with my algorithm. So I'll need to check and see what the logic is in here. Maybe that's the problem. And then they return false. So anyway, this is apparently a solution that works. So you can check this out if you're dying to know how to get this sort of output with this grid here. You can go ahead and do that. Check it out for yourself. Otherwise, hold off. Wait for me to come up with a solution. I'll try not to look into that code and try to solve it on my own. But there you go. That is all I will say for now. Thanks so much for watching all the way to the end, and have yourself a wonderful day. Can't wait to see you in the next broadcast. Take care of yourself.